All right, this one and this one is successful and that one's successful. We got 3 successes. Otherwise it's success, success, success. So 0.9 times 0.9 times 0.9, otherwise known as 0.9 to the third power. The chances that all 3 surgeries are successful is about a 73% chance. Although this is not actually accurate in real life. Does anybody know why?
Each surgeon is different.
Each surgeon is different. In fact, that is a very good point. So on a whole, this is true data, by the way. Everything in this book is true data according to when the book came out, which was like 2013 or something. No, 2016, I think. So overall, rotator cuff surgeries overall are 90% successful. That doesn't mean that you could just have one off. Like, for example, what if suddenly they were like, Laura Nussbaum, you're a surgeon? And I'd be like, uh-oh, I never went to medical school. And they'd be like, get in there. And I'd be like, guess what? I don't think there's a 90% chance that my surgery is going to make it. You know, like, pretty sure I'm going to fail. But then to balance out your really bad surgeons, you have excellent surgeons who almost have like an excellent track record and almost never fail. And then together as a whole, the group of them are 90%. So individually, it changes, but let's assume that everybody is the same. B says, find the probability that none of them were successful. That means that we had 3 failures in a row. The first one failed, and the next one failed, and the next one failed. So this one's 0.1 times 0.1 times 0.1. Only a 0.1% chance that all of them fail. Unless, of course, Laura Nussbaum has the knife and is forced to do it, because I would not want to. Now, this one is a hard question. And this is something that I don't feel like anyone really completely understood, so I want to have an in-depth conversation right now. So, right now, you might be doing this. You might be saying, okay, at least one of them fail, or at least one of them is successful. So give me, Justin, a scenario where at least one of them is successful.
Fail, success, fail.
Fail, success, fail. Okay. If I wanted to figure out this one, I would take 0.1 times 0.9 times 0.1. .009. That's the chances that specifically the first one fails, the second one succeeds, and the third one fails. But it says at least one of the 3 surgeries is successful, right? So what's another option? Success, success, fail. In fact, we could have had 2 successes and then a fail. And that would have been 0.9 times 0.9 times 0.1. But just so you're not confused, Georgia, and probably everybody else as well, this right here is specifically the situation where the first surgery fails, the second surgery is successful, and the third surgery fails. I could also say, what about the first one being the successful one and the other 2 ones being the failures? Okay, so that's also 0.009. Or if I said, what if it went fail, fail, success? That's also 0.009. Do you see how I'd have to figure out a whole bunch of these and add up all of these different numbers together? It is way faster instead to say, what's the probability, what's the thing that can't happen? Because I could have 1 success, or I could have 2 successes, or I could have 3 successes, right? What's the only thing that can't happen? 3 fails. So we're doing the complement. So if you take 100% minus the probability of all of them failing, you get your answer this fast without having to figure out all the different possibilities. By the way, there are 7 different possibilities we would have had to figure out, add up all those 7 numbers, and they would have added up to 0.999. But it's way easier just to do this one.